everyone, my name is Olivia Haley and I'm a graduate student at Kansas State University. So my project deals with agricultural water quality, and I'll be turning off my video for the rest of the presentation so that you can see my entire screen instead of my little box right here. Alright, so tell me if these symptoms sound familiar. Stomach cramping, nausea, vomiting, and many trips to the bathroom. Did you get it? I'm describing the many symptoms of foodborne illnesses. According to the Centers for Disease Control, 48 million Americans will catch a foodborne illness each year. That's 1 in 6 Americans. Many foodborne outbreaks have been linked to contaminated water used in growing or processing fresh produce. This is called agricultural water. Federal guidelines mandate that agricultural water must be of safe and adequate sanitary quality if it is to come in contact with the edible portions of fresh produce. This quality is measured by the concentration of E. coli, which is a fecal indicator. Definitely not something you want to think about being too high in your water. But some water sources naturally contain more E. coli than others. For example, surface waters like ponds or streams have a much higher risk of fecal contamination because they are more open to the environment than groundwaters like wells or municipal water, like the water that comes from your tap. But they tend to be more accessible and cost-effective to use. But why do we even care about this in the Midwest? Well, many growers use surface waters, and there is yet to be a study which gives a big picture of E. coli contamination and water sources on Kansas and Missouri produce farms. This is a bit risky if we want to continue the massive increase in specialty crops. In our study, we analyzed water quality data from 3 laboratories, which tested ground and surface water sources on different farms in Kansas and Missouri. They tested the water samples using the Call-Alert Quantitrade 2000 method. In brief, 100 milliliter water samples were collected from different water bodies and dissolved in a reagent that would either turn yellow or fluoresce according to the presence of E. coli. We compiled the information from the databases and compared the concentration of E. coli in the different waters. What we found was that the majority of the samples came from surface waters, the riskiest type of water source. And not surprisingly, these samples had the highest average concentration, even higher than the safe level for production established by the federal guidelines, which is the dotted line in Figure 2. Groundwater was the next most common sample type and had a significantly lower average concentration, but the microbial risk still wasn't at 0. In big picture, this means that groundwaters are common, but that surface waters are more so, and we require the help of agricultural extension agents and programs to spread the word about safe water use practices. Not only will this safeguard public health, but also the growing specialty crop industries in these states. We also have to figure out why these waters contain so much E. coli. Is it a lack of water treatment methods? Or are there none even being applied? These are the questions for the next phase of the project. And since I'd have time, I'd like to go over more about the unknown category, because I think this can be a source of confusion for some of the readers. So this unknown category contains all of the samples which we couldn't identify as either ground, surface, or other, which was largely municipal waters. And as you can see, this unknown also exceeded the limit for safe use in production. But what does this mean? So this means that these unidentified water sources have a high risk for microbial contamination, but we aren't able to say whether or not we should be investigating groundwater, or should we even be investigating municipal water or surface water. This presents another avenue for extension outreach, where we can guide growers in how to fill out the forms that accompany the samples with the laboratory, so that we can be able to attribute these unknown categories into either ground, surface, or municipal water sources, and build a better water microbial quality profile for Kansas and Missouri. Thank you so much for watching my presentation. And of course, please let me know if you have any questions. Bye-bye.